Hello, fifth grade mathematicians. Today we're focusing on entry task day 97. Let's read problem number 1. Max has 285 ounces of juice. He pours an equal amount of juice into 5 pitchers. Enter the number of ounces of juice in each pitcher. So whenever we have a math problem, we want to focus on what do I know? And in this case, we know that Max has 285 ounces of juice. So I'm going to draw a tape diagram that shows what he has, and we're dividing or splitting what he has into 5 equal amounts. So we're going to write this as 285 ounces. And it's also juice, so I'm just going to write that down there. And we're splitting it into 5 equal amounts. And the question is, so each of those is going to be a pitcher. And the question is, how much goes in each pitcher? So we have a division problem, and we're going to solve that using the standard algorithm. 285, the whole goes in the house, and we have 5 equal pitchers. How much goes in each pitcher? I know that 5, can't start there. 5 goes into 28 5 times. 5 times 5. Five goes into 35. And we end up with no remainder. So my answer would be 57 ounces. Now I want to check my work here. And I had 57. I just want to double check and make sure that 57 times 5 would end up being what we started with, which is 285, and it is. So over here I'm going to write 57, and again we're asked to write it in ounces. Okay, problem number 2. Which set of steps shows a correct strategy and solution for subtracting 3 3/7 minus 2/4? So what do I know about this type of a problem? We know that whenever we add and subtract, we can only add and subtract like units. Since we're dealing with fractions, we're going to have like units or like denominators between 7 and 4. As I look at my possible solutions, I also have to understand that sometimes there's more than one way of solving things, but we have to take the possibilities that they give us and see if they will work or not. So there are a couple things that I notice right away. Number 1, all choices between A, B, C, and D, they all have are coming up with the common denominator. 7 times 4 or 4 times 7, which is 28. So that doesn't really give us a clue as to which ones may or may not work. The next thing I know is that when I have a fraction and I'm making it into a common denominator, in other words, 3/7, how do I make it into 24ths? And how do I make 2/4 into 24ths? And so I know that whatever I multiply my original fraction by, I can't change what the value is, but I can change what it looks like. And the only way I cannot change the value is to multiply it by 1. So in this case, I have to multiply 3/7 times 4/4. And over here, if I'm making an equivalent fraction, I would have to multiply it by 7/7. And we see that 4/4 and 7/7 are equal to 1, so it doesn't change the value, just changes what it looks like. So let's look over at our choices here. I know that I cannot choose A or B because it does not, neither one of those problems changes the original fraction into an equivalent fraction. But let's look over at C and D. Now C has what I have shown over here. In other words, it has 3/7 times 4/4, and it has 2/4 times 7/7. However, if I look up at the problem, it's 3 3/7 minus 2/4. So we cannot have C because it does not account for the whole number. So if I look at 3 3/7, how do I make that into an improper fraction? And remember, I'm going to show this over here. It's 3 3/7 minus 2/4. So I can make 3 3/7 into an improper fraction by multiplying my denominator times my whole number, and with 3 times 7 is 21, and then adding my numerator. So it'd be 24/7. And I can see over here that I have 24/7 times 4/4. So it would be D. Would be the only possibility. Okay, let's go ahead and examine problem number 3. The area of the base of this right rectangular prism is 24 square centimeters, and the height is 10 centimeters. We're told to enter the volume in cubic centimeters of this prism. So remember, we talked about this a few lessons ago, that volume is three-dimensional. So I know that area is two-dimensional, and we're talking in this case of a rectangle. Area of a rectangle is length times width. It's only 2 dimensions. The volume of a rectangular prism is 3 dimensions. So it's our length and width, but then we're also going to multiply it by the height. Now, if we look at our information, it says the area of the base of this right rectangular prism. So the area of the base of the right rectangular prism is 24. So a couple things here. I want to point out the area of the base. So if we look at the base, that's this shaded part right here. And it is telling us that it's an area. So we have already been given 2 of the dimensions. Now we don't know exactly what those dimensions are. In other words, we know that the area, whatever the length and width are, is equal to 24. So at this point, we don't have enough information to know exactly what the length and width are, but we know that the product of the length and width are 24. So it could be 3 times 8, it could be 4 times 6, it could be 2 times 12, it could be 1 times 24. But that's not important because we don't need to identify the exact dimensions. We're just looking for what the total volume is. So we know that the product of the length and the width is already 24, and then we are given the height. Whoops. The height, which is 10. So I can then multiply the base, which is 24, times 10, and that's a simple calculation. It's 240. Again, there's a reminder over here to write our answer in cubic centimeters. So we have 240 centimeters cubed. That's how I like to write it. You could also write it 240 cubic centimeters. However, wherever my little m went, kind of went off the edge there. But whatever you prefer, it really doesn't matter. So please reach out to your teacher if you have any specific questions about any of the problems that we've done. Have a great day.